The next factoring technique that we have to learn is a technique called factoring by grouping. With factoring by grouping, it is most commonly going to be used when you're given a polynomial that it consists of 4 terms. Now that's not to say that that is the only time that it will be used, but that is the most common usage. So let's go ahead and look at an example. If we had an x squared plus a 7x plus a 3x plus 21, since this does have 1, 2, 3, 4 terms, then grouping is the technique that we're going to try and use. Now, when you're asked to factor by grouping, one piece of advice I'll give you is don't be tempted to combine like terms. If I was to take this expression and combine like terms, I would have only 3 terms instead of 4, and I wouldn't be able to use this technique. So if you're given 4 terms and you're told to group, then go ahead and keep it 4 terms. Now, basically the way the technique works, as you're looking through these 4 terms, you notice that you have a potential for a GCF in more than one place. For example, x squared, 7x, and 3x have a GCF of x. But that's not a GCF for all 4 terms because you can't take it out of the 21. The 7x, the 3x, and the 21 could have a GCF, but again, there's nothing that's common to all of it. 7 is common to the 7 and the 21. 3 is common to the 3 and the 21. But again, no matter how hard you try, there's not a GCF that will come out of everything. So the idea is to take these 4 terms, split them up equally, 2 and 2, so that the 2 you've put together have a GCF. Now, it was convenient for us this time to put the first 2 together and the last 2 together. That particular grouping won't always work. Sometimes you have to put together the first and the last, and then the middle 2, or the first and the third, the second and the last. There's different possibilities you can try, but we're going to go with what we have here. We're going to go with this because I notice in the first 2 terms I can pull out an x. In the next 2 terms I can pull out a 3. Now, a very important thing for you to pay attention to is this is the point when you know for sure that you have a grouping that's going to work for you. You know this because you've pulled out a GCF once, twice, and doing that has revealed yet a 3rd GCF, and that's the x plus 7. So I will pull out the x plus 7. Once it is out, the x plus 3 is all that's left, and you've completely factored this. Alright, so let's try that again. Let's see how that works one more time. Let's take an x squared plus a 2x plus a 5x plus a 10. And we see we have 1, 2, 3, 4 terms. Grouping is the technique we will use. You notice the first 2 have a GCF. The last 2 have a GCF. As a matter of fact, the second and the last have a GCF. The first and the third do as well. So which grouping would be best? Well, sometimes they both will work. Sometimes only one of them will work. So we'll just try what we've got. We'll put the first 2 together and the last 2 together. Out of the first 2, what comes out? Let's think about it. An x squared, a 2x. Yes, x comes out. Over here, a 5x, a 10. It's a 5 that comes out. And like I said before, now you know that you did it right. Why? X plus 2 is a GCF again. Bringing that out leaves an x plus 5 behind, and again you've finished. Now, something we have to be very careful of with this type of problem is negative signs and subtraction signs. Let's say we had a 10c squared plus a 25c minus 6c minus 15. The first two have things in common that can factor out, so do the last. So that's how we'll group. We'll put the 10c squared plus 25c in one group. Since there's a minus sign here, I have to put a minus sign in the middle. And in the last group, we'll put a 6c plus 15. Now watch carefully what has happened to your signs. This minus sign right here has acted as if you factored out a negative 1. That's why the minus 6c became a 6c, and the minus 15 became a plus 15. Now let's look and see what we can take out. Out of the first one, a 5c will come out, leaving a 2c plus 5. Out of the second one, a 3 will come out, leaving a 2c plus 5. Again, we're at the point where we can look and say whether or not we made a good grouping. The fact that the 2c plus 5 is another GCF that can be taken out, leaving behind a 5c minus 3 tells us that was a workable grouping, or a very good grouping, to get the problem done. Now, this technique will work with four terms whether you have one or two variables within the problem. Let's say we had a 3y minus 9 minus xy plus 3x. Now we got two variables here, but we'll still be able to work the problem because we have four terms and we can group. Now, let's try a different type of grouping. We've been doing first two, last two every time. Let's show that other types of groupings can also work. Let's put the first and the third together. So I'll have a 3y minus xy together. And then the second one and the last gives me a minus 9 minus 3x together. Again, when the minus sign comes out, the signs change. That's why you saw that change. In the first one, y comes out, leaving a 3 minus x. In the second one, a 3 comes out, leaving a 3 minus x. Did the grouping that I picked work? Yes, it did, because 3 minus x is another common factor, and y minus 3 is what you're left with. Now, this technique will work also with higher powers. Now, something that I haven't done is actively looked for GCFs for the whole problem. And that's because first few examples you simply didn't have one. But if you run into a situation where there is a GCF, that is always the first thing you go for before you use any other technique. So with this next problem, I have a 9, a 6, 45, and a 30, an x cubed, an x squared, another x squared, and an x. So I can pull out a GCF of 3x this time around. That leaves me in here a 3x squared plus a 2x minus a 15x minus 10. And this is what I'm left to group with. Now I will again group first two and last two. And when I group these last two, what's going to happen? The minus 15 will become a 15x, and this minus will become a plus. Just like we said before, when you pull that minus sign out, you have to treat it like a minus 1 has been factored out. And of course, the 3x is still out there. Out of this first pair, this first binomial, an x will come out, leaving a 3x plus 2. Out of this second one, a 5 will come out, leaving a 3x plus 2. Now, since you already have a GCF out front, what happens now that you notice you've got another GCF? Well, I'll continue off to the side. The 3x was a GCF that was already out. The 3x plus 2 is another GCF, so it'll just go next to the one you already had. And with that out, x minus 5 is all that's left. So we factored using factoring by grouping with a higher power. Now let's do a couple more examples. where we're working with even more variables. Let's look at a 3a plus a 6y plus a y plus 18. Now, see, the first two have something in common, so I'll put them together, and by default, the last two will go together. Out of the first two, a 3 will come out, leaving an a plus 2y. Out of the others, it would appear nothing comes out. So what has happened? Well, we finally ran into a problem where not just any grouping will work. This grouping that I have chosen just won't work, so we need to try something else. Start back with the original problem. And let's see, the first two had something in common, but the last two didn't, so we need to rearrange. It would appear that the first and the last have something in common, so we'll put those together. And the middle two also have something in common, which would be the y in this case, so we'll put them together. Out of the first two, 3 comes out. Out of the second two, we're going to have a y coming out. And is this a GCF? Well, remember, addition is commutative and associative, etc. So yes, it is the same thing. So we'll just call it a plus 6. Once it's out, a 3 plus y is what's left. Let's try one more of those, where just not any grouping at all will work. Let's look at an ax minus 21 minus a 3a plus a 7x. First two have nothing in common, so we definitely don't want to put those together. As a matter of fact, first and third doesn't seem to have anything in common, so we don't want those together. Let's do first and last. So I'll put the ax plus 7x together, and that's an a. Alright, a minus comes out, and we'll have a 21 plus 3a. Out of these first two, an x comes out, and you're left with an a plus 7. Here, 3 comes out, and you're left with a 7 plus a. Again, these are in fact the same thing. And once that is out, x minus 3 is all that's left, and you've finished your factorization. So there basically is factoring by grouping, which is really not much more than pulling out GCFs multiple times once you've established a grouping that'll work for you.